Hey, what's up, guys? We're gonna do superpower on Leetcode. Uh, there is a prereq for this problem, and you need to have done the power problem on Leetcode, which is where you implement finding some number raised to some power, the result of a number raised to some power. So yeah, I'm assuming that you've done this problem, okay? And if you haven't, I did a video on it. You can go watch it, and yeah, so that's just a prereq. So my assumption is that you did that problem at some point and you still understand how to do it. So anyway, I'm going to do superpow. So what's our algorithm here? So let's just say I have a raised to the, or let's just say a is some number and my power digits here. Let's just say that that is 2, 5, and a 4. So that would just mean that I have a raised to the 254, right? So what we're going to do is we're going to loop through these one by one by one. And so let's just say in the beginning, I'll just have one digit, and I'll just have a squared. Well, what happens when I get to the 5, right? Like this is what's going to make things interesting. Well, what I can do, I essentially have to turn this, so like a to the, so let's just say a to the 25th, or yeah, a to the 25 is equal to a to the 20 times a to the 5. Okay, we can all agree on this because when we multiply exponents, we just add the powers, right? But how do we turn this 2 into this? Well, what we can do is just say a to the 2 raised to the 10th. Because when we raise a power to another power, we multiply. So this actually equals a to the 20th. So what we're going to do is we're going to take, so let me just start. So let's just say we took our a to the 2, raised it to the power of 10. That essentially shifts it by, like, it basically adds a 0 in there. So what we're going to do is we're going to say a to the 20th times a to the 5th equals a to the 25th. And then on the next digit, so when we get to the 4, what we're going to do first is we're going to take our previous result, which was a to the 25, which is the previous result. We're going to increase him to the power of 10. And that'll give us a to the 250. And then what we're going to do is we're going to take that result and multiply it by the digit that we are currently on, which is 4, which would give us a to the 254. Cool. So this is essentially the algorithm. We're going to basically on every digit, we're going to take our previous result and increase it by a power of 10, which essentially shifts it over so that we can add in the next digit or the next power or the next exponent. Sorry, I'm mixing up terms here. But yeah, I think you guys can see it. Just take the previous result raised to the power of 10 and process our current digit. So let's actually code this out. I'm going to comment this out just to just in case I need it later. But anyway, let's code, before we do anything, we need to code a simple power function. So we're going to do private int pow, and this will take in the number, and this will take in the power. And we're going to return a result. So int result1, and why? Because let's just say the power was 0. Well, anything raised to the power of 0 is just 1. So that's why we're starting at 1. And we're going to say while power is greater than 0. So again, this is based on the power problem. If you haven't done it, you need to go do that problem. But I'll talk through this a little bit. But yeah, I'm assuming that you've done the power problem. So we're going to check if the digit is a 1. So if power, or if the least significant digit is a 1, then we want to take our result and multiply it by our a. And we actually need, so they tell us that they want us to mod our powers or our results by, they want us to mod our result by some number to keep it within a certain bound. So that's actually why I have this private final static int mod 1337. So this is the number they gave us in the problem that they want us to mod by. So we're going to mod this by mod. And then we need to double our a's. Then we need to shift. We need to basically remove a digit. So let's do that. We shift out, we take out the digit, and now we can just return our result. Okay, cool. And oh, this actually needs to be a times a, so I can mod it just in case it gets really big. Okay. So again, this would get like really big, so I just want to mod it just to be safe. I think that's it for the power function. Did I do everything right? I think I did. All right. So now let's actually pretend that so now we have this nice pretty little power function, and now we can actually write the actual algorithm that we wanted to, that we were talking about, where we take our result, we mod it to a power of 10, or mod it to a power of 10. We increase it by a power of 10, and then we add in our current digit. So let's get into that. So we have a result. We're going to return the result. C equal 1. We need to loop through our numbers. So int I equals 0. Actually, we don't even need an I, do we? No, we could just loop through. We could just grab a digit. So int digit power digits. Okay. And we want to say result equals. So again, we need to take our previous result. So pal of our previous result, which is just 1 currently, and we wanted to raise it to a power of 10. Well, 1, this is okay because 1 to a power of 10 is just 1, right? So let me just type it out so we don't lose track. So this is just 1 to a power of 10 equals 1. That's all this is for the first iteration. Then it'll get interesting. I'll explain what happens on like the second iteration. So, and then we want to take our current digit and, no wait, no sorry. We want to take our number, which is a, and raise it to the digit in our power digits. Okay. So that would be, so let's just take this example here of A254. So all I'm saying here is, let me make this closer. Okay, so this would be 1 to the power of 10, which is just 1, times a raised to the power of 2. Cool. And then on the next iteration, what's going to end up happening is we're going to do a to, so this would just be 1 times a to the a squared is just a squared, right? So then we would have a squared, which would be our result here. A squared would be the result on the second iteration. And we're going to raise that to a power of 10. And then we're going to multiply that by the next digit, which is a to the power of 5. And this whole thing will give us, so this would be a to the 20th times a to the 5th, which gives us a to the 25th. Cool. And on the next iteration, we're going to take our previous result, raise it to the power of 10. And that'll give us 250, a to the 250, and of course we do a to the 4, which equals a to the 254. Okay, so that's all that code is doing right there. And are we done? Is that the entire problem? I think that's it. Oh, and then I got a mod. I can't forget the mod because then it just ruins the whole problem. Let me do that really quick, and then I'll submit it so that we can confirm that it's right. Okay, cool. So let's run this. Oh, this is just operator precedence. I always forget this. Power and 1. Okay. And I have a wrong answer. What did I do wrong? Result times a shifted. I went through every digit. Did I? I feel like I messed up a mod. Oh, okay. I know it. I forgot to. Okay, so the test case I'm failing is they gave us the max integer as A. So I actually need to mod the input. So we're just going to do A mod equals mod. Cool. And that should give us the right answer. So let's just make sure that works. Cool. So that's the whole problem. Yeah, I hope this helped. And if you guys have any questions or anything, you can ask in the comments. But if it helped, you can give it a thumbs up and you can subscribe if you want. Cool. Bye.